You're watching The New Stack Makers, a podcast for people who develop, deploy, and manage at-scale software. For more information and articles about at-scale technologies, please visit thenewstack.io. Now enjoy the show. Hey all, it's great to be back again for another episode of The New Stack Makers. And today I have an old friend and colleague, Janakiram MSV. Janakiram is a noted analyst. He's done a lot of consulting in his day. Whenever he's at the big events, he's out hanging out with all the big wigs because they want to hear exactly what he has to say. So I know they're going to be wanting to hear what he has to say about services as software. In other words, how AI agents are scaling and how they are really affecting how we think about software as a service. Johnny, it's great to have you here.
Same here, Alex. Great to be on your show.
Well, listen, so when we talked a few weeks ago, we were talking about AI agents. And in that discussion, we focused a bit about why services as software is going to change the way we think about software as a service. Can you help us see why that is significant and what it's meaning right now?
Absolutely. So before we get to service as software, let me step back and talk about two parallel streams that are constantly evolving. The first stream is how data has evolved from 1980s to where we are today, right? Initially, for us, data was all about spreadsheets. If you remember Lotus 123, Microsoft Excel, the initial days, it was just data. And data didn't make much sense. It was like Acme sales, Q1, 400, what does it mean? It was just a piece of numbers or strings put together, and it was not making much sense. And then in 90s, we saw the relational database. And if you compare this with, let's say, a small business that started with Lotus 123, then it moved to, let's say, multi-region SMB company, and they had databases that were running in multiple locations. So they switched to relational databases from using simple spreadsheets or just a data-driven software to more of a relational database. So that was the next wave where data became slightly more accessible, and also it turned data to information. That was relational databases. And from there, we went to getting historical data with data warehouses. So that was the third wave in the evolution of data. So data warehouses gave us the data to knowledge to information. So it became more informative. You could do historical trends. You could do very complex queries on historical data, and it became more of a knowledge, right? So from data warehouse, we eventually got to big data and data analytics, where we started to see insights. And that's where even the unstructured data came in. Data lakes became a big thing. And we started to pull data from social media, from non-structured data, like PDFs, images, and a variety of sources. And big data became the thing. And that gave us insights into information and knowledge. And then came predictive analytics. That was really the intelligence part of it, where data eventually became much more intelligent, and people started predicting and forecasting all of that. So data turned to intelligence. But that's where everything stopped for a long time. Today, if you look at any CRM software like Salesforce, or if you look at any ERP software, it brings you till that point, and it shows you what needs to be done, and you have to ultimately perform. So if there is a lead that has come out based on your big data, social media campaigns, and all of that, it is you who need to send out an email to that lead saying, hey, we have a product and you are our prospect. Do you want to really talk? Do you want to buy this? Right? Now, that is how the data has evolved. Now, on the other side.
So let me ask a question about the data evolution. And through that, we saw the evolution of NoSQL databases.
Right.
And we saw the evolution of data stores as a
Right.
capability. And this starts to get into questions about how does the hardware and the infrastructure actually play a role, where
Right.
we think about the memory, right? Like we saw the rise of in-memory databases, for instance,
Right. Right.
right? We
Yeah.
saw the real-time cache emerge.
Right. So all of them fit into one of these pockets. For example, when you're dealing with um unstructured data, NoSQL played a very important role in evolving that. In-memory databases complemented OLTP. So all of them fit into somewhere in this spectrum where we translated data to intelligence, and all of them actually acted to accelerate this evolution. But what is very important is uh, the other track that I started off with. I said two parallel tracks
Right.
that started evolving, right? So the other track, which is very, very aligned with what you're actually talking about, is how our compute infrastructure has evolved,
Right.
right? So initially it was mainframes. Everything ran on a mainframe, DB2, COBOL, the 80s. And then came desktop, and desktop revolutionized access to data. You could actually use a Windows terminal or uh, a Mac back in early 90s or mid 90s to access information. So from mainframes, we came to desktop, and desktop became client server, and client server became distributed, and then came web, and web, along with web and mobile, came cloud. So from very centralized to, we moved to highly decentralized and distributed. And cloud, one of the flavors of cloud is SaaS. So compute evolved and stopped with SaaS as the delivery of applications. So that is the other track that I was talking about.
That is the other track that you're talking about. So we have the evolution of data, we have the evolution of compute infrastructure, and now we see the evolution of what coming from those two convergences.
Right, absolutely. So, when we look at the software as a service uh, milestone, as I mentioned earlier, SaaS is obviously the front end for the data. Without data, Salesforce, Workday, or SAP, or any of these applications, they mean nothing, right? So there is data behind them. So there are two important trends that are going to converge. The first trend is, remember, SaaS is a tool, and it is just an enabler. It For example, when you're filing taxes, you're using SaaS, right? Your TurboTax is actually a SaaS, but it takes you to a point where it's optimizing your tax calculation. It does everything, but you have to file your taxes by yourself, right? Uh, so it is leaving the action to the end user. So
Right.
SaaS, uh, it brings you till the last mile, but lets you do the final step. Now, uh, in the evolution of the data, the intelligence is what SaaS currently provides us, but the next step to that is action, and that's where AI agents come in. So we have seen data become information, information become knowledge, knowledge become insight, insight become intelligence, and what is the next step? That is action. And that is where AI agents will come in. And how does this impact the other track, which is the compute track? So remember, we talked about mainframe, desktop, client server, web and mobile, and then SaaS. So for the next step in SaaS, it is the agentic workflow. So on one side, data is becoming more and more actionable, and on the other side, compute is becoming more and more dynamic and agentic. So when these two converge, we have a new paradigm which is called service as software.
And services software then calls on agents to perform that last step or a series
Exactly.
of last steps.
I'll give you an example. Now, a lot of confusion comes in because we already use this term called service in SaaS, software as a service. But for a while, forget that definition. Today, service is anything that someone can offer and deliver, right? For example, you want to file a legal petition, you go and meet an attorney, right? Now, the attorney will help you file a petition or a case, or even he will advise you whether it is worth filing a petition or not. Now, what he's delivering is service, right? Similarly, you go through a master health checkup, you get all your blood markers and your health biomarkers, and then you take it to a radiologist or someone who is qualified, and he'll say, hey, your reports are fine, but you should go meet a cardiologist because your cholesterol levels are high, or you should meet an endocrinologist because your diabetes, your blood sugar levels are slightly high. Now he's delivering a service. He's looking at the reports and he's delivering a service. Now that service that has been traditionally delivered by lawyers, radiologists, even doctors, and subject matter experts are going to be delivered by agents. So when we say service as software, we are talking about the traditional sense of services which are going to be automated and delivered by the new era of actionable software, which is an agent.
So what does this mean for the enterprise software teams out there of the world? So the software engineers, the DevOps professionals, the DevSecOps professionals, the teams that really manage the software infrastructure, that develop it, that deploy it, that manage it.
Yeah, so they are not going to be impacted immediately. This is going to impact the business software makers, particularly the SaaS companies. I'm sure you heard of Satya Nadella claiming SaaS is dead and AI agents are going to take over SaaS. It made quite a big storm in the industry. So what he actually meant was precisely this: SaaS comes all the way till the end and leaves the action to the end user, but agents will close the loop by actually performing the action. So what it means is, instead of you looking at your CRM software and deciding to mail 20 prospects, an agent will not only pick up those leads, it will send out an email exactly in your language. And similarly, if you are negotiating a contract renewal with a current existing incumbent customer, the agent will be able to do that by effectively interacting in a conversational style with your current customer, modifying the contract and extending it and sending it, going back and forth and closing the loop. So you will actually be the authorizer of this transaction or this mutual conversation, but you don't have an active role. You are a passive spectator while this entire thing takes place. So this is going to impact software as a service players significantly, because what they have been delivering is going to be extended effectively by agents.
So these agents then will scale tremendously, but how do they get created in the first place?
Great question. So, and for that we have to step back a little, and this is not a completely new paradigm. Today, we have organizations that are exchanging business documents like invoices, advanced shipping notices, purchase orders, uh, and this exchange of documents and workflow orchestration has been done through very niche software called enterprise application integration. For example, back in the day, be a WebLogic, IBM, WebSphere with MQ series, Microsoft BizTalk, and SAP, all of them played a big role in enterprise application integration. So those enterprise application integration or EAI workflows are highly rigid, deterministic, and predefined, well-defined, step-by-step rules engines, right? So they are basically rule engine that says every time a PO comes, do this. Every time an invoice comes, do this. Now, guess what? We have a very brainy, capable software in the form of LLM. Now, this LLM doesn't need to have a predefined rules engine attached to the workflow. When you actually say, hey, I got this purchase order and it has so and so values, the LLM can come back with the next step that is very intelligent and very contextual for that transaction. And then this LLM will need access to internal data, internal software. And that's where we have this new ecosystem that is building up called tools. So when you bring tools to LLM, they suddenly gain limbs. If you think of an octopus, the LLM is the brain, and all the limbs of the octopus are basically the tools. And these tools are capable of calling an internal SAP endpoint, or talking to a line of business application, or calling an external Stripe API to close a payment, or they can do anything. So these agents basically have a few attributes. Number one is they need brain, and the brain is coming from LLM. They need limbs, and these limbs are coming in the form of tools. Tools are nothing but functions and APIs that empower these octopuses to perform better. And the third one is memory. They cannot be stateless. They need to preserve the state as they go along. So they need memory. Once
That's
you bring all of them,
I'm sorry, that's an interesting point too, right? Because LLMs have largely been stateless.
exactly. So agent is basically a wrapper on top of LLM that has access to external software via tools. It has memory, both short-term memory that is very transactional and in memory, and long-term memory that is persistent and can help an agent retrieve historical information. So when we create this software, a new piece of software that can interact with LLM, that can interact with tools, that has memory, that software is actually called as an agent. And this agent is capable of autonomously performing a task dynamically without having an if then condition, or a rigid rules engine, a static rules engine. It is capable of performing autonomous dynamic workflows at runtime based on the contextual environmental issues or aspects.
Who do you see deploying agents right now?
We are just getting started. There are multiple frameworks that the developers can use, and all these frameworks are essentially the frame. They give you a prescriptive mechanism to talk to an LLM, to add tools, to add memory. So currently, we are in the very initial, very nascent phase of experimenting with what the agents are capable of. They are not deployed yet. Uh, Currently, the enterprise is still experimenting with AI assistants and co-pilots. Agents are the next step in that direction. Uh, but currently, developers are dealing with frameworks like LangChain, Llama Index, Crew AI, Microsoft Azure AI Foundry, AI agents, the agent. Salesforce has recently announced Agent Force. All these are those platforms and frameworks that will let developers build. And Alex, most interesting aspect is this reminds us a lot of the evolution of containers, right? So
Yeah, I'm thinking of
we
containers.
are very, very in a phase, very similar phase of using one container with Docker run and saying, "Wow, I've written portable software that can run anywhere, run once, deploy anywhere." So agents are currently enjoying that Docker moment in their evolution, where we get excited by writing one agent, but that is just the beginning. We are going to face the challenge of orchestrating and scaling agents, and we need Kubernetes for agents.
We need Kubernetes for agents. What do you mean by that?
Right. So I just compared agents with Docker containers,
Right.
right? Uh, there are some similarities and differences between Docker containers and agents. First of all, is the state. Containers are stateless, whereas agents are very stateful. They need memory. Uh, if that is a difference, the similarity is like a container, agents are single task oriented, they are atomic, and they are highly transactional. So, in a lot of ways, you can compare one agent with one container or one microservice. Now, initially, Docker has given an amazing developer experience, and we could run one container, maybe two containers, or maybe three. But when we dealt with more than a dozen containers, we realized Docker doesn't cut it, and we looked at Kubernetes. Now, similarly, today we are running one or two agents and we are excited and we are able to see the potential. But when we run tens and thousands of agents, we need an orchestrator that can manage these workflows and manage the entire life cycle of agents. So we need Kubernetes for agents.
We need Kubernetes for agents, but it's not Kubernetes. It's something else.
Well, Kubernetes is very well positioned. I've been the advocate of Kubernetes as the universal control plane.
Okay.
And we have seen Kubernetes orchestrate clouds with, for example, Crossplane. We have seen Kubernetes orchestrate VMs with KubeVirt. Well, Kubernetes is technically very well designed to orchestrate agents. Someone will have to bridge that gap by building a controller, scheduler, and an operator for Kubernetes to orchestrate agents. But technically, Kubernetes design principles align very well with orchestrating agents.
Due to their architecture that we see with the whole kind of way that they clusters are developed through the nodes and such. Is that correct?
Right. Yeah, that is the underlying infrastructure. But for someone who is building an agentic workflow, it might require multiple agents to work in concert, in coordination. So Kubernetes already has a phenomenal control plane that can scale from one node to 1,000 nodes or tens of thousands of nodes. Now imagine Kubernetes control plane has a joint Siamese twin, which is an LLM. And every time you create an agent with a task, Kubernetes control plane will send the task to the LLM, and the LLM says, I got to break it down into 6 steps. Now, each step will have to do this function. Now, every step will turn into a new sub-agent, and the Kubernetes control plane will spin off those many sub-agents, and it will hold control of this entire workflow while the LLM acts as a guiding force. You know where we are going?
Yeah, we're going to huge scale. First of all, and so because and when I talked to Maya Kozkowski the other day about OAuth, she talked about computers, VMs, containers, and even a small organization might have 500,000 agents. This requires tremendous amounts of memory. If each one of these agents essentially is some state, right?
Absolutely.
So that's an issue, right? I mean, do we need better memory? Do we need more memory? And what raises questions. Mark Hinkle said to me about the DRAM market, for instance.
Yeah, so the memory of agents is very unique. As I mentioned earlier, an agent will have to maintain 2 types of memory. One is the short-term memory, which is maintained in the context. For example, think of it like a scratch pad where it goes, does something, comes back, makes a note of it, and it needs to access that. That is the short-term memory, which is in-memory contextual memory. Then there is long-term memory that's going to preserve the conversations between agents, the transactions between agents. And the best thing is that memory is not really associated with RAM. It can be compressed, serialized, and pushed onto a disk as some protobuf or some format. So the advantage we have here is all of that can be serialized, and we don't really need like machines with terabytes or a lot of memory. We can effectively swap in and swap out because the agent will require to extract short-term memory from a pile of long-term memory and use it for the workflow. So it's not a huge challenge because a lot of that memory can be serialized and saved on disk.
So there's tremendous challenges ahead. We're thinking about the orchestration of agents, for instance, and that alone has lots of questions about scalability, but not just scalability in terms of the number of agents, but scalability of monitoring and performance and that observability. Can you speak to
Absolutely.
those challenges? And are those the core challenges that are facing enterprise architects?
We haven't seen that yet because no one has deployed agents at scale. We are yet to encounter those challenges. But given the historical trend, we are very soon going to hit that milestone, right? All the challenges that you mentioned, actually, many of them are not very new. Observability, we solved it. Thanks to open telemetry today, observability has become very mature, and a lot of those pillars can be adopted by agents. And in fact, LLMs are already using open telemetry based observability for for tracing and for evaluations and all of that, which is actually a good news. uh, the other big challenge would be evaluating agents, and making sure that the agent doesn't go like haywire and does something which is not supposed to be done. So we need to have control on these workflows, and we need like a supervisor agent and then subordinate agents, and there are going to be a lot of patterns, and some of these patterns again are very well defined in the microservices architecture. So it's going to be a very interesting combination of the lessons that we have learned from building, scaling, deploying, and managing microservices to building, scaling, and deploying agents, because there are a lot of similarities there.
Mm. Hmm. So the near-term challenges, the near-term trade-offs that we are seing, what would you
Right,
think? What are some of those that you think about right now in terms of the trade-offs?
right. So currently, y- you know, uh, the developers are not thinking of the patterns that will give them a very repeatable mechanism to deploy agents, because none of the traditional software principles will work with agents. We need to adopt newer patterns and newer principles of designing and developing agents. So you need a different mindset when you're developing an agent, because you are letting the power or control go away from your code, and you're letting an LLM take over. So you have to come to terms with that. So, while there are a lot of lessons that we can learn from microservices and deployment, that is more on the infrastructure side. But on the development side of things, developing an agent is net new task for a lot of developers. We have not done that, and there are not many best practices out there. So we have to evolve certain patterns and some best practices of developing and designing agents. Those are going to be very tough challenges ahead. And then we need an agent server. I don't know whether it's Kubernetes or something else, but this communication between the agent server and the agents, uh, those protocols. How do we make them talk to each other, and what language do you use for that? Will the agents will evolve their own language, or do we use existing protocols like gRPC, REST? We don't know. That is going to be another evolving area, agent to agent communication.
I get the sense that we're entering a intermediary phase right now then.
Absolutely, absolutely. There are some lessons that we have learned and we can borrow. There are some absolutely new challenges that we haven't even thought of, and 3 years from now, 2 years from now, we are going to be in a very different era.
Well, Johnny, thanks so much for just giving a good analysis summary of AI agents and the transition from software as a service to services and to services essentially, and then how we're going to think about this intermediary phase and what it might mean for us in terms of scalability, in terms of development, deployment, and management, in terms of the security, which we didn't even get into, but we could talk about that another time.
Sure, sure. Great. I enjoyed the conversation.
If you like this video, please give us a thumbs up. And if you'd like to see more videos like this, you can always subscribe to our YouTube channel. We're on all the major social media platforms. You can always find us at thenewstack.io. We hope to see you soon.